Welcome everyone. We are discussing integration by the method of partial fractions. I have already taken 2 classes for this chapter. Number 1, when denominator can be factorized into linear factor but not repeated. And number 2, when denominator can be factorized into linear factor but some repeated. Today through this video I will consider case 3. When denominator can be factorized into quadratic factor but not repeated factors. So problem number 1. 5 dx by x square plus 1 into x plus 2. Dx by 1 plus x square plus x cube, and x dx by x plus 1 x square plus 1 and x plus 1. Now look, degree 0, degree 3, you can apply it. It is quadratic but not repeated. For linear non-repeated, we know the rule, a by x plus 2. So they are of same type. So consider problem number 2. Dx by 1 plus x square plus x cube. So factorize. So we have not solved this type of problem. This is cubic. So try to factorize. 1 plus x square common, 1 plus x. So dx by 1 plus x into 1 plus x square. This is quadratic factor, not repeated. What is the rule? So let 1 by 1 plus x into 1 plus x square. For linear factor, we know the rule, it is not repeated, so a by x plus 1. For quadratic factor, 1 plus x square, you have to express it in terms of x plus any quadratic. If it is 1 plus x square, then it also be x plus c. So this is our. Then same procedure. Apply comparing coefficients, you find a, b, c. So 1 equals to a into 1 plus x square. So bx plus c into 1 plus x. Now if we put x equals to minus 1, so this factor is 0. So x equals to minus 1 implies 1 equals to a into 1 plus 1 implies a equals to half, because this part is 0. Now if we put this equals to 0, then x is imaginary. So we put only real values. 1 plus x square 0 means x is imaginary. So we have to put other values of x or compare coefficients. So comparing coefficient of x square. Look, this is 1 x square. There is no x square. So 0 equals to a into x square. So coefficient is a. Bx plus px into x, bx square. So a plus b. Comparing coefficient of x square. Left hand side is free from x square, so this is 0. And this is a into 1. Bx into x, so coefficient is b. So this implies b equals to minus a equals to minus half. Minus half. So we have the advantage because we have already find a. So we get b. By putting x equals to minus 1, a equals to half. Then comparing constant term constant term. So constant term to left hand side, this is 1. A into 1, this is A, not involving x. So bx into 1 not possible, x into c, so c into 1 is constant term. So 1 equals to a into 1 and c into 1. So what is c? C equals to minus a equals to minus half. So this is our main aim, to find a, b, c. Now putting values of a, b, c in 1, what we are getting? 1 by 1 plus x into 1 plus x square. A equals to minus half. A equals to minus half. So A equals to minus half. So what is C? C equals to minus A. So this is plus half. This is plus half. So A is plus half. B is minus half. B is minus half. And what is C? C is A equals to B equals to minus A equals to minus half. B equals to minus A equals to minus half. Equals to minus half. So C equals to minus A and A is half. So this is minus half. Sorry. So we are getting A equals to half. A equals to half. And B and C as minus half. So putting values we get this. Now integrating both sides with respect to x. So dx by 1 plus x into 1 plus x square. Half outside dx by x plus 1 minus half outside x plus 1 by x square plus 1 to x. Now this one is simple. This is half log mod x plus 1. This is minus half. This is x dx by x square plus 1. Half dx by x square plus 1 plus 1. Now look, we are dividing it into two parts because second one dx by x square plus 1 is standard, tan inverse x. This one also, look, this one also x square plus 1, derivative is 2x. So this is f dash x by fx. So log fx form. So it is half log mod x plus 1 minus 1 by 4. So it is 2x. Derivative of x square plus 1 is 2x. So it is log x square plus 1. We can write it directly minus half tan inverse x plus c. Plus c. Here it is c1. Again one integration constant. Adding we get c. So listen again. Dx by this. Factorizing we are getting this. One is quadratic, one is linear. So this equals to a by x plus 1. For linear, rule is bx plus c. So your main aim is to find b and c by putting values of x or comparing constant term, coefficient of x and so on. So putting value of a, b, c, you get integrand in standard form and write value of integration. So 1 and 3 exactly same. You try to solve 1 and 3. Now we consider some problem. X square dx, x square plus 1, x square plus 2. X square plus 1 dx, x square plus 2 is even power. dx by x whole minus 1. Now look, it is quadratic factor but not repeated. This is degree 2, this is of 4. So if we use the earlier method, then look, x square plus 1, x square plus 2. We have to use x plus b by x square plus 1, cx plus b by x square plus 2. So it is very difficult to find the constant. So look, what we will do for this type of problem. If rational function, this is rational function, fx by gx, fx and gx are polynomial. If a rational function contains a rational function contains even power of x, then we put even power. So even power is x square. Then we put substitution and try to express it as linear factors. Because for linear factor there is only one constant. So look, this is even power x square. This is also x square plus 1, x square plus 2. So consider problem number 6. So we put x square equals to u. Now we do not take the whole integration. We consider only this one. X square plus 1, x square plus 2 by x square plus 3, x square plus 4. We only take this part. We are putting x square equals to u but not differentiating because here x is not present. So it will be u plus 1 into u plus 2 by u plus 3 into u plus 4. Now it is of linear. So you can express it as partial fractions of linear partial fractions. So let, what is our rule? U plus 1 into u plus 2 by u plus 3, u plus 4. Now look, it is of degree 2, it is of degree 2. So you can apply it directly. So you have to divide it, but since they are of same degree, so we can find the quotient by trial method. Here coefficient of u square is 1, here coefficient of u square is also 1. So we can write it as 1 plus a by u plus 3, b by u plus 4. So we have already considered it. That is why we are writing it directly in part 1. Mind it, this is of first degree, this is of second degree, this is of second degree. So not applicable because denominator must be of greater degree. But you can find what is quotient. This is u square, it is u square. So 1. Then numerator is of degree 1. You can apply it. So directly we can write the integrand in this form. Now u plus 1 into u plus 2, u plus 3 into u plus 4, a into u plus 4, b into u plus 3. This is a special type. Now you have to find a and b. U equals to minus 3 implies, because u plus 3 is a factor. So minus 3 plus 1. So this is minus 2. Minus 3 plus 2. This is minus 1. This part is 0. A into minus 3 plus 4. Minus 3 plus 4. This is 1. This one is 0. So this implies A equals to 2. A equals to 2. So U equals to minus 4 implies U plus 4 is occurring. So minus 4 plus 3. So this is minus 3. This is minus 2. So this part is 0. This part is 0. So minus 4 plus 3. So B into minus 1. So B equals to minus 6. B equals to minus 6. Now putting values of A, B, C. So 1 implies. So 1 implies U by this. 1 plus A is 2y. And what is B? Minus 6y. So we are getting this equation. Now put value of U. What is U? U is x square. So x square plus 1 into x square plus 2. X square plus 3 into x square plus 4. 1. 2 by x square plus 3 minus 6 by x square plus 4. Now this is, if we take integration, we get, so taking integration on both sides, integration dx, integration dx. So we can easily integrate. What is the integration? This is x. This is 1 by root 3 tan inverse x by root 3. So this is 2 by root 3. And this is 6 by 2 tan inverse x by 2 plus 3. Because x square plus 4. So we get value of the integrand in this. So listen again. If numerator and denominator each of degree 2, put x square equals to u, but do not take differentiation because x is not present. Without taking differentiation, you use method of partial fraction. Then putting value of u in terms of x, you can integrate both sides. So this one 4 and 5 is very simple. Next, problem number 7. dxy x4 minus 1. So we can factorize dxy x square plus 1 into x square. So by inspection we can express it as a sum or difference. You look, x square minus x square plus 1. Yes. So if we put it plus, then it will be 2x square, but it is only 1. So you can write it this as x square plus 1 minus x square plus 1. So this as half, meaning remaining same. So half of this and this. Look, x square minus 1 and x square plus 1 is LCM. X square plus 1 minus x square plus 1. So this is 2. So 2 is balanced by. So this one is of standard. So 1 by 2 into 1 log x minus 1 x plus 1. And this is half tan inverse x plus 6. And if it is of this form, x square dx by x4 minus 1, suppose this is 8, then it is of even. So x square by this. So look, we can put x square equals to u, then try to find a and b by using method of partial fraction. But for simple problem, you can find the constant by trial method. Look, if it is x square and if you put here plus, then x square plus 1 x square minus 1. So 1 cancel, this is 2x square. So make it balance by half. So it will be only plus. So this should be remembered. So for quadratic factor, if there are two quadratic factors, it is very difficult to find the constant. That is why we use alternative one if possible. And finally, integration sin x dx by sin 4x. This is 9. Now sin x unchanged. This is 2 sin 2x into cos 2x dx. Now sin 2x is again 2 into 2, 4 sin x cos x and cos 2x. So sin x is cancelled out. Now cos x into cos 2x. This is cos x into cos 2x. Now listen, cos 2x. So cos 2x. So this is 2 cos square x minus 1 or 1 minus 2 sin square x. We can write it 1 minus 2 sin square x into cos x, and this is dx, and 1 by 4 outside. We can also write it 2 cos square x minus 1. So if we put it in this form, what advantage we are getting is this. If we put sin x equals to u, so cos x dx equals to du. So 1 by 4. So this is cos x dx, and this one is cos square x into 1 minus 2 sin square x. Now what is cos x dx? So look, this is du, and sin x equals to u. Cos square x is 1 minus u square, 1 minus 2u square. Now it is of previous form. So you can integrate it by trial method or putting or using transformation. So look, 1 by 4, if we try to express it, 1 minus 2u square as a difference, 1 minus u square. So 1 minus u square, and this is 2u square. So we take here 2, because your main aim is to cancel 2u square. So 2 minus 2u square. 2 minus 2u square minus 1 plus 2u square. So this one is cancelled out. You are getting 1. So meaning is same. So we can express it in this form. In this form. Or you have to use method of partial fraction using u square equals to p. Now 1 by 4, this is 2 by 4, du by 1 minus root 2u whole square minus 1 by 4 du by 1 minus u square. So half of 1 by 2a, 1 by 2 into 1, log 1 minus root 2u, 1 minus root 2u. Mind it is linear, so it will be multiplied by 1 by root 2 again. So you put here 1 by root 2. due to presence of this root 2. Otherwise, you have to take 2 common to make coefficient of u square 1. This is 1 by 4 log 1 by 2 into 1 log 1 plus u by 1 minus u plus c. Sorry, this will also be 1 plus x by 1 minus x. So putting value of x, u, we get value of the integral. Mind it is 1 by root 2. So 1 by 4 root 2 log 1 plus root 2. What is u? U equals to sin x. 1 minus root 2 sin x. 1 by log 1 plus sin x, 1 minus sin x. So this is the process. So today, through this video, we have solved some important problem of integration by method of partial fraction when denominator contains quadratic factor but not repeated. You practice the rest of the problem. Thank you for today.